Okay, so the first question on the calculator section tells us to look at the frequency table. Just for a very quick refresher, this means that as far as our data set, there was a 2, a 4, a 7, a 10, and 11. And in fact, there was not just a single 2, there were 8 2s in our data set. There were 15 4s in our data set, 21 7s, 28 10s, and 3 11s. That's how our frequency table is set up. So it asks us to write down the mode. Knowing that the mode is just the number that shows up the most, we see that there is a frequency of 28. That's the highest frequency, and that is when x is 10. So there are 28 10s, so that is our mode. Then it asks us to find the value of the range. The range is just the largest number minus the smallest number in our data set. 11 was our highest number, 2 is our lowest number, so our range is 9. The next one says find the mean, and there is a way we could do this by hand. The way that would be to say 2 times 8 plus 4 times 15 plus 7 times 21 plus 10 times 28 plus 11 times 3, all divided by the total frequencies. So that's 8 plus 15 plus 21 plus 28 plus 3. Or there's a way that we can do it on our graphing calculators, which I'm going to show you, especially because the next question, I believe, asks us to find the standard deviation. Sorry, it actually asks you to find the variance, so we're going to actually do that on this page right now. To find the variance, that is the standard deviation squared. So I'm going to show you right now how to find the mean and how to find the standard deviation on your graphing calculator. We'll see if I can do this. Okay, so in order to find the mean and the standard deviation, the first thing I'm going to do is go here to Stat. And I'm going to open my lists by choosing Stat and opening Edit. And here I see my two lists, L1 and L2. And in L1, I've already gone ahead and done this, but you should do this. Put in your data values, 2, 4, 7, 10, and 11. And then in L2, we're going to put our frequency lists right there. Once you've done that, press Stat again. This time we want to calculate something. And we want to calculate one variable statistics because we only have one variable. It's one list. The frequency list is not its own variable. It just tells us how many there are of every data point of the variable that we have. So we're just talking about the one variable. We want to make sure that when we do this, that in the list it says L1 because that's the list that we're trying to calculate the mean and the standard deviation for. And then here, we do have a frequency list. Some of you, when you open this, it might not have this. It might just be empty. You need to make sure you put in L2 as our frequency list. You can do that by doing second and then 2. And then you are going to hit calculate. And that X with the bar over the top, that's our mean, 7.15. And then this right here is the standard deviation, 2.906054982. So what we're going to do now is we can write down that we know our mean is 7.15, rounded to 3 sig figs always if we have to round, and that our variance, which is 1D, is going to be 2.906054982 squared. And I do want to use that whole thing because I don't want to compound any rounding errors. And when we do that, we get, when we round to 3 significant figures, we get 8.45. Okay, so this is a transformations question, and we're trying to figure out what happened to transform this f of x into this g of x. And so one of the ways that you might do this is, first of all, you might rewrite that g of x has to be ln of 1/2 x and then plus 3. I didn't change anything about g of x, I just rewrote it so that it's easier to look at and it's more in the typical format. So essentially what we've done is we have put 1/2 x in the place of x. So the way that I would write that is we have done f of 1/2 x, and then we've also added 3 to the function itself. So plus 3 is on the outside there. So we have these inside transformations and these outside transformations. The inside affect it horizontally, outside affects it vertically. So here, whenever we're multiplying by x and it's on the inside like this, that's going to be a horizontal stretch or compress. But you have to keep in mind and remember that for horizontal transformations, this 1/2 is not the scale factor. It is a stretch or compress because of the 1/2, but the scale factor for horizontal transformations is 1 over b, so 1 over 1/2. So 2 is the scale factor for the horizontal stretch. So that tells us what Q is. Q is 2. It's a horizontal stretch by 2. Then we also have to think about just general translations, shifts left or right or up or down. If there was plus C in here, that would tell us that there was a shift left or right. But because there's not, there is no horizontal shift. So that's a 0 shift horizontally. And then vertically, this plus 3, that is our vertical shift. And it goes up 3, so positive 3. So when I've used this transformation vector here, H is the horizontal shift, K is the vertical shift. Just like with vectors, H would be the X value, which is horizontal, and K would be the Y value, which is vertical. So all it's trying to do is understand if we know what transformations, these transformations are being applied. So for this question, it asks us to find the y-intercept, and we know that the y-intercept is whenever x equals 0. So we can just go ahead and substitute 0 for x. And simplify. And we know that anything to the 0 power is 1. So e to the 0 gives us 1. 5 times 0 is 0. So that just leaves us with negative 10. Plus 3. So negative 1/10 would be negative 0.1. Plus 3 would give us negative 2.9. And generally, whenever it says find the y-intercept, they would like you to write it as an ordered pair because it is a set, it's a point. And so you wouldn't just write negative 2.9, although I think in this question they would have given you credit for it anyway. Another method would be to go ahead and graph it on your graphing calculator, and it looks like this. And then you could press second, calculate. The first option is value. And when you do that, plug in 0 for x. And it gives you 29/10, which is a good thing I just did that because it's not negative 2.9, it is positive 2.9. So that is a oops for sure. Okay, so that is our first question. Second question says find the equation of the vertical asymptote. Whenever we are looking for the vertical asymptote of anything, it's always going to be that denominator set equal to 0. And so we set that denominator equal to 0, and we get 5x equals 10, So that gives us x equals 2. That is our vertical asymptote. And if we look at our graph, that looks like that fits here as well. It looks like there is an asymptote vertically there at 2. The last question says, find the minimum value of f of x, so the minimum y value, when x is greater than 2. So if we're talking about when x is greater than 2, we're talking about purely to the right of that asymptote. So when you look at that graph, it's pretty easy to see that the minimum we're talking about is whatever that point is right there. It's that value at the bottom. So the easiest way to find that is to just use your graphing calculator and have your graphing calculator find that. So let's take a look. Okay, so when we're looking at this, we are going to want to calculate this minimum right here. We can see it. We just want to find out exactly what that value is. So we're going to press second to calculate. This is again where we got the value for when we wanted to know what y was when x was 0. But now we're not looking for the value anymore. We're looking for a minimum. So we're going to open up minimum. And I'm going to move this cursor all the way until I see it up here. And I want to make sure it's to the left because it says left bound. And then hit enter. And then move that cursor to the right of the minimum and then hit enter. So now it shows these arrows and it's going to calculate the minimum in that space. And then guess, I'm just going to line my cursor up with about where I think it is and hit enter. And so it says that my minimum is at essentially 3.00 and then 7.02. So we got 3.00 when rounded to 3 sig figs, and then 7.02 when rounded to 3 sig figs. And so that's the minimum ordered pair. But we have to be careful to recognize that it doesn't say find the minimum ordered pair. It says find the minimum of f of x. Well, f of x is y, so it wants to know what is the y value, what is the lowest y value, and for that, the answer is 7.02. Okay, so this question is a probability question. It tells us that the probability of someone being left-handed is 0.08. It also tells us we have a sample of 150 students, and K is the number of expected people, the number that we would expect for how many left-handed students there could be. So it's the expected value. This, we have to recognize that this is binomial distribution or a binomial probability, and the reason we know that is because of a couple things. The probability of someone being left-handed is always the same. It's always 0.08. We're talking about a repeated trials. We're repeating the trial 150 times. And the outcome of one is not going to impact the outcome of the other. So the first person I talk to, whether they're left-handed or not, is not going to impact the next person that is surveyed. So this is binomial probability. There's a formula for the expected value for binomial probability, and it's n times p. The number of trials, or the number in the sample, times the probability of success, where left-handed is a success. So all we're going to do is just multiply 150 times 0.08. And that gives us 12. And I'm going to put 12 students to be really precise. Okay, then it says, hence find the probability that exactly K students are left-handed. So we're trying to find out the probability that exactly 12 students are left-handed. So we're going to write it like this. Now, when we do this, we're going to do it on our graphing calculator. So on our graphing calculator, this is a binomial distribution, we already said. So we're going to go to this distribution here, which is on the vars, second vars, which is the distribution menu. And we're talking about a binomial distribution, so scroll all the way here, and you're going to see there are two choices, Binomial Pdf and Binomial CDF. Keep in mind that PDF is, you can think of it as precisely, the probability of there being precisely 12 people who are left-handed, versus the CDF, which would be the probability of there being up to 12 people who are left-handed. So we want PDF because we want to know the probability that there's exactly 12. We know there's 150 trials. We know the probability that one person is left-handed is 0.08. And then X value is the probability, we said, of X equals 12. What's the probability that exactly 12 people? And we're going to go ahead and hit enter. And there's our answer. So that gives us 0.119. Then it says, find the probability that fewer than K students are left-handed. So now we're talking about what's the probability that fewer. It doesn't say fewer or equal, it just says fewer. So that's less than 12 people are left-handed. That's what we're trying to find. Now, whenever we find a binomial CDF, your calculator is always going to calculate less than or equal to whatever number you put in. Always, always, always. So we always have to take whatever we're trying to find and rewrite it as a less than or equal to statement. Well, the probability of X being less than 12, that less than 12 people are left-handed, would be the same as there being 11 people or less. Because there can't be a half person, there can't be 11.5 people. So the next option is for there to be 11 people, which would be included in the less than 12, or less than that. So we're going to go back into our calculators. And we're going to go back into the distribution. And we're going to go to binomial CDF this time. We're accumulating. What's the probability of there being up to 11 people that are left-handed? So we still have 150 trials. We still have a probability of being left-handed of 0.08. But then our X value is 11 because it's saying up to and including 11. And when we do that, we get 0.457. So 0.457 is my probability. You should know that there were 2 marks for this problem, and the only way to get a mark if you got the wrong answer, the only method point was to write something that indicated that you recognized that you were doing the probability of being less than or equal to 11. Okay, so this question says that it's showing us a chord, AB, and they tell us that the circle has a radius of 8. So I'm going to go ahead and draw that in first thing. If here's my center, then I know that the radius must be 8. So both of these values must be 8. That helps because it gives us a triangle. And then I'm going to just go ahead and label this theta just so that we have it labeled. And then we know the value 12. So it says find the area of the shaded segment. So with geometry, a lot of times our goal is either to try to find ways to add up little small parts of the shaded area to get the whole shaded area, or to do something where we say, I'm going to try to find the entire area of this sector right here, and then subtract away the area of the triangle. Like that. And then that will leave us with this part that's shaded. So my strategy is going to be find the area of the sector and then subtract the area of the triangle. Now, there's a great formula for the area of a sector. And the formula for the area of a sector is 1/2 theta r squared. And the only trick is that theta has to be in radians. And then there's also a great formula for the area of a triangle, which is 1/2 AB sine of C, where A and B are 2 sides, and angle C is the angle between those 2 sides. So when we look at this, we can tell that we have the radius, we don't have the theta. We have the two sides, 8s, but again, we don't have the angle between them, the theta. So really, our job is we have to find theta. So how can we do that? Well, to find theta, we look at it, and when we know 8, but we don't know its angle across, we know this 8, we don't know the angle across, we know this 12, we don't know the angle across. That's what rules out the law of sines as an option. You have to have a pair, like a complete set, to be able to do the law of sines. So that tells us we're going to have to use the cosine rule, which looks like this. And we have to be careful that C is the side that's across from the angle we're trying to find. So I'm going to write minus 12 squared because that's the angle we're trying to find, is the angle across from 12. The other two sides are both 8. And now we're just solving. So that gives us cosine of C equals negative 1/8. And so now we're going to need to take cosine inverse of negative 1/8, and you need to make sure that your mode is in radian mode. So cosine inverse of negative 1/8 gives me 1.69612. And I know that's really long, but we don't want to have rounding errors, so I'm keeping it pretty long until the end. Now that we know theta, we can go ahead and go back to this line and say, well, we have 1/2, we know theta, we know the radius, so that's complete there. And then over here we have 1/2, the two sides are 8, and the angle between them is 1.69612. So now we just have to type that into our calculator. So when I do that, I get 22.5, and we're talking about area, and it said it was in centimeters, so we're saying centimeters squared. Okay, so this says, find the term, the x to the 5th term, in the expansion of the derivative. So before we can do anything about the expansion, we need to find out the derivative, f prime of x. To differentiate, we're going to have to use the chain rule. So du dx is 2x, dy du is 7u to the 6th. Remember that when you use the chain rule, the inside function is u, then you replace that with u, so we have u to the 7th, that's the y. And then you differentiate each of them. And then the chain rule says multiply dy du times du dx. So that's 7u to the 6th times 2x. And then we need to make sure that we replace u with what it was originally. So we get that. So next what we're going to do is let's go ahead and simplify 2x times 7. That's 14x times x squared plus 3 to the 6th. So that is the derivative. So now that we have the derivative, we're looking for the x to the 5th term when we expand this. Well, whatever is expanded from here is going to then be multiplied by 14x. So it's going to increase the exponent by 1 because there's this x here. So we're looking for the x to the 4th from this expansion, and then once we get that, we multiply by 14x. So let's just remember how to do an expansion here, and I'm just going to start by focusing on this part. When we expand that, we would start with 6, choose 0, then the a term to the 6th, and then the b term to the 0. And then the next one would be 6, choose 1, the a term to the 5th, the b term to the 1st, and so on. So when I start looking at these, this right here would give us x to the 12th. That's way too big. This would give us x to the 10th. That's way too big. So it's 6 choose 2 times x squared to the 4th. That's going to give us x to the 8th. That's way too big. 6 choose 3 times x squared to the 3rd times 3 to the 3rd. That gives us x to the 6th. That's still too big. But what about the next one? 6 choose 4 x squared to the 2nd, 3 to the 4th. That's right, because that is going to, that term right here is going to give us an x to the 4th as its term. And then we're going to take it and multiply by 14x right here. So we have 14x times 6 choose 4 times x squared to the 2nd, which is x to the 4th, times 3 to the 4th, which is 3 squared is 9, 9 times 9 is 81. So we just need to simplify. X times x to the 4th, that's x to the 5th. We have 14 still. 6 choose 4, the way you do that is type 6 in your graphing calculator, then press the math button, move all the way over to probability, and choose the button that says NCR, and then type 4. 6 NCR 4. And that gives us 15. And we have 81 here, so now we're going to multiply 81 times 15 times 14, and that gives us 17,010 x to the 5th. Just in case you didn't catch that, to get this, you type you'd type 6, then you'd type math, then you'd move over 3 times to the probability menu. You'd choose the number 3 that says NCR, and then you'd type 4. Hopefully that helps. Okay, so it asks us how much time is there between the first low tide and the next high tide. Here's our first low tide, here's the next high tide. We're looking at time, so we're looking at the x value. So the first low tide is at 6.25. The first high tide after that is 12.5. So if we subtract 12.5 minus 6.25, that gives us 6.25. Let's see, hours. 6.25 hours. Then it asks us to find the difference in height between the low tide and the high tide. So that's the y values that we're looking at. So the high tide is at 1.5 and the low tide is at 0.6. So that gives us 0.9 meters. Oh, I definitely did not mean to press that. Okay, 0.9 meters is the difference. The next 3 sections ask us to find P, Q, and R. So as a quick refresher, remember that P is your amplitude, and a negative P is possible. It would cause a reflection in the graph. Remember that B, which we're calling Q here, 2 pi over that coefficient of the x, or the coefficient of the t, is going to give you the period, and R gives you the vertical shift up or down. So we know the period, or we can quickly find the period, because this right here is half of the cycle, right? So if we double considering. Okay, so when we look at this, here is the equation that we wrote with P, Q, and R. And it says there are 2 high tides on December 12th. What time does the second high tide occur? Well, they tell us that when t equals 0, when they're starting this, it's 2100 hours on December 10th, which means it's 3 hours until the end of the day, until midnight on December 10th. So after 3 hours, when t equals 3, that will be the night, that will be when December 11th starts. And then 24 hours later, when t equals 27, that will be when December 11th ends. Well, we're talking about December 12th. So December 12th starts at 27 hours, and then 24 hours after that, when t equals 51, that's when December 12th ends. So December 12th takes place from 27 to 51 for t. The easiest way to figure out what time the second high tide occurs is to just look at your graph in your graphing calculator. So go ahead and type it into Y, and then go ahead and graph it. So go ahead and type it into your graphing calculator. Make sure your mode is in radian mode. And then I'm going to go ahead and set my window. I know that we're talking about between 27, when time is 27, and when time is 51. So I want my x to start at 27 and end at 51. And then as far as high tide and low tide, I could easily go from 0 until the max was like 1.5 or something. So I'm just going to say from 0 to 2. And so we see it. So it's talking about the second high tide. Well, this isn't quite a high tide, right? It's almost, but it's not quite. So here's the first high tide on December 12th. Here's the second high tide on December 12th. So that's the one we're trying to find. So I'm going to say second calculate, maximum, and I'm going to scroll and make sure that I get my tick mark here to be to the left of the maximum where I hit enter, to the right of my maximum and hit enter, and then my best guess for where the maximum is and hit enter, and it tells me the time is 49.965. Now, it tells us that it's about 49.965, so we can write that down. T equals 49.965, which, when we round to 3 significant figures, gives us t equals 50.0, basically. So, what hour of the day is that? Well, we're going to need to go ahead and subtract 27, which is what the day started at. It started from 27, and that leaves us 23, and that 2300 is the time, or you could write 11 p.m., where the second tide occurred. Now, if we know that the shaded area is 30% of the distribution, we also know that to the left of the mean and to the right of the mean is 50% each. So if to the left of the mean is 50% and the shaded area is 0.3, that leaves us 0.2 or 20% for when p is less than, the probability of when x is less than 9. It also tells us the standard deviation equals 2.1, and it asks us to find mu. Anytime it's asking us to find the mean or to find the standard deviation, we absolutely have to use a z-score. There's no getting around it. So the first thing I would do is write the equation for a z-score, which is on your formula sheet. And so when I do that, I already know some of the information. I know what that mu is what I'm finding, and I know the standard deviation is 2.1. As far as x and z go, that is where we have to find a standardized z-score. So we know that the probability from up here of x being less than 9 is 0.2. So when x is 9, the probability is 0.2. So I can put 9 in for x. However, I need to know what is the z-score when the area is 0.2. So now we're considering the standardized normal curve, where we still have the same little section here, that's 0.2, and we're just saying, what's this z-score? Thinking about the mean being 0 and the standard deviation being 1. That's the standardized normal curve. So the way that we're going to do that is we're going to calculate the inverse normal. So you're going to go to second distribution. You're going to go to inverse normal. For area, we're going to put 0.2. And we want to know the z-score, so we're going to put 0 for the mean and 1 for the standard deviation. And that is going to give us the z-score. So when I do that, it gives me z to equal negative 0.8416212, and so on. And so that is my z-score, negative 0.8416212. And so now I just have an equation I need to solve. I multiply both sides by 2.1, and that gives me negative 1.767, ... Then we are going to subtract 9 from both sides. So that gives me negative 10.76, ... And then divide both sides by negative 1. So we get 10 point, and I'm going to round to 3 significant figures, so that's 10.8. So the trick is always to put in for x a value that you know, and to find the z-score associated with that x by using the area that you know. Okay, so this one, it's really hard to work your way through the language, but it's basically setting up a different normal distribution. So our other normal distribution, I'm going to draw over here, and we called that variable x. And the mean we found from the last problem was 10.8. And the standard deviation was 2.1. Over here, our new one has a mean that we don't know, but they're calling it lambda. And it has a standard deviation of 3.5. It tells us that these two events are independent events, and it gives us the probability of the intersection. Well, there is a formula from your formula sheet for independent events, and so that's the first thing I'd recommend that you do, is to take a look at that. So I'm pulling it up just to make sure I write it exactly as it's written in your formula sheet. It says probability of A intersect B equals the probability of A times the probability of B. So we can actually say that we know that the probability of the intersection here is 0.4, and that means that that's the probability of x being greater than 9 times the probability of y being greater than 9. Well, the good news is the probability of x being greater than 9, we know that from before. We had 9 right here, and the area to the left of it was 0.2. So the area to the right of that, greater than 9, is 0.8. So we can divide both sides by 0.8. And 0.4 divided by 0.8 is 1/2. So that tells us the probability in this new distribution of y being greater than 9 is 1/2. Well, what does that mean about 9 then? If the probability of being greater than it is 1/2, 9 has to be the mean, because the area to the right of it is 1/2, and the area of it to the left of it is 1/2. So we just found the mean to be 9. Okay, the last question, let's draw out another normal curve showing what we know. We now know the mean is 9. We also know the standard deviation is 3.5. It says, given that y is greater than 9, find the probability that y is less than 13. So somewhere over here, and I don't know where, I'm just going to mark 13, we want to know basically what's the probability that it's between that 9 and 13, given that we know that it's already greater than 9. So because it says given that y is greater than 9, what we can do is we can actually go ahead and cross off this whole side of the normal distribution. It's not going to be over there. We're no longer including that because it says given that. So that's going to be a pretty high probability because we're talking about any of the area here out of that total area. Well, how do we find the probability that it's between 9 and 13 in the first place? That's where you're going to go ahead and go, x being between 9 and 13, and you are going to go into your distribution, and we always use normal CDF or inverse normal. We're going to use normal CDF because that's when we are trying to find the area. The lower bound is 9. The upper bound is 13. The mean is 9. And the standard deviation, they told us, is 3.5. So when we do that, it gives us a probability of 0.37345099936. Okay, now that's just the general probability that it's between 9 and 13. But that doesn't take into account the fact that we're assuming that it's already greater than 9. So that we don't need to include this 0.5 at all in our probability calculations. So when you think about it, we're talking about conditional probability here. And there's a formula for conditional probability, which you can use or you can reason it out. But the formula for conditional probability says the probability of A and B equals the probability of A times the probability of B given A. So we're trying to find the probability of B given A. The probability that it's between 9 and 13 assuming or given that it's already greater than 9. That's what we're trying to find. Well, that means that probability of A, that's the probability of it being greater than 9. And this probability of it being both greater than 9 and between 9 and 13, that's what we just found. Do we know the probability that it's greater than 9? Absolutely. That's just 50%. So now we have 50%, or 0.5, equals 0.373450, times the probability of B given A, which is what we're trying to solve for. So we're just going to divide both sides by 0.5, and that gives our probability in our final answer, which gives us 0.747. This one's kind of a doozy to try to understand, but keep in mind that all of a sudden, when you have excluded this whole area, that green chunk looks really big, right? It's a big proportion of the area that we're talking about. So if we already know it's not in this this part that I'm scratching out, then we're just talking about what's this area out of this total area here. And so that's why we have the 0.373 out of the total area of 0.5.